So for every problem we take. Okay, because like I kind of see a lot of backtracking problem. It does not seems to be, like it's not looks very difficult, but it has to be solved, like using a backtracking problem. Like usually people don't see it. Okay, so we will, like first of all, let me, like start with the prerequisite of backtracking. What are all the prerequisite of backtracking? See, backtracking is not an efficient approach, I would say. It is not very efficient paradigm of algorithm. But there is a separate type of problem called as enumeration type of problem. What kind of problems can be called as, like, first of all, I'll tell you how to identify whether the problem is decision problem or optimization oriented problem or otherwise, like enumeration. The three main category types of problems, I would say. So first thing is, I will just take one simple question, example question, where I will just take a same question, same concept, and I will explain the question in three different contexts. And when I explain that in three different contexts, automatically the problem will, like you will understand when a same problem is taken and explained in some way, it becomes decision problem. The same problem is taken and explained in another way, it becomes optimization. The other way, it becomes, like enumeration problem. So we'll first of all discuss. There is a problem called as there is a problem called as M coloring problem. It's a graph related problem. We don't want to know about graph to understand this problem. It's a very basic problem. So coming to M coloring problem, okay, M coloring, you could have learned this theoretically also in your mathematics paper. But what is this M coloring paper is, when you take a graph with a N vertices and M edges. For example, let me take a very simple graph, which is vertex 1 I'm taking, then vertex 2 I'm taking, vertex 3 and a vertex 4. Consider every vertex to be like a city. And let this be city 1, C1, and let this be city 2, C2. This is city 3, C3, and this is city 4, C4. Okay. So the map, you find 4 cities like this. And now what I do is, there is, like connectivity of roads between cities. I'll tell you that city 1, city 2 have a direct road connection is available. But from city 1 to city 3, there is no direct road connection. Then from city 2 to city 3, there is a direct road connection. From city 3 to city 4, there is a direct, like road connection. City 1 and city 4 also, we have a direct road connection. There is no, like direct connectivity between C1 and C3 and C2 and C4. Okay, such a kind of graph I'm taking. So this is road 1. So this is road 2, R2. And this is road 3, R3. And this is road 4, R4. Okay. See, coming to M coloring problem, what M coloring problem says is that, let me consider all the cities like as vertex, right? They are all vertex independently. So two vertices can be called as adjacent vertices when they are connected directly by a particular edge. Edge is what I mean by road. If two adjacent cities are directly connected, okay, if there is if two city is directly connected by a like a road, then we call it as adjacent cities. First of all, for example, when you take C1 and C2, they are two different cities, but they are connected by a road called as R1. So C1 and C2 can be called as adjacent cities. But C1, C3 cannot be called as adjacent cities because they are not directly connected by a road. Either we need to reach C3 via C2 or otherwise via C4 we need to reach. So directly I'm not having any road that connects C1 and C3. So it cannot be called as adjacent cities. So now the question is, first type of question I will ask you. Okay, so what happens is, I give a set of colors. M coloring problem, in the sense, what is M coloring is, for example, like I need to color all the cities using different color I need to do. No adjacent city should be colored with same. Okay, no same color should be, like done for the, like for the cities which is adjacent. So C1, C2 cannot be colored the same. Okay, they cannot be given the same color. C2, C3 cannot be given the same color. C3, C4 cannot be given the same color. C4, C1 cannot be given the same color. So we need to color every city such that no adjacent cities are, like given the same color. That's a procedure of M coloring problem. See, what is the scenario? That you take a map. In the map, you find there are 4 cities available. And when you look at the direct connectivity of the 4 cities, C1, city 1 and city 2 is directly connected by a road. City 2 and city 3 is directly connected by a road. City 3 and City 4 is directly connected by a road, and City 4 and City 1 is directly connected by a road. So when two cities are connected directly by a road, we call those two cities to be adjacent cities. We call it to be adjacent cities. Now, we need to color every city. Okay, we need to be coloring every city, C1, C2, C3, C4, such that no two adjacent cities should be given the same color. If it is adjacent cities, they should be of different color. C1, C3 can be of same color because they are not adjacent. C1 also have same color and C3 also can have same color. But C1 and C2 cannot have same color because they are adjacent. So adjacent cities should be colored with different. Okay, they have to be given with different color. Whereas non-adjacent cities, they can have same color. No issues with that. That's what the basic idea of M coloring problem is all about. Now, M coloring problem, I will give you three different questions. The first question is, okay, I give a graph. First of all, a graph is given. Okay, graph G is given, and also the number of color is also provided. Graph G is given, and a value M is also provided. Value M. M is the total number of color which can be used. Now, by knowing what is the graph, the structure of the graph, okay, number of vertices, number of edges, which vertex is connected by which vertex, which edge is the edge is connecting which vertex and the which vertex, all this information is available. And the number of color is also provided. Now, you need to check whether using the number of color, whether the graph can be completely successfully colored by following the rule that we have. What is the rule? Rule is very simple. Adjacent cities cannot be given the same color. So using the number of colors provided, is it possible to fill all the cities that we need to check? Either true or false we need to say. Yes, well, all the cities can be colored with the help of the M colors provided, or it is not. No, this graph cannot be colored. All the cities cannot be colored with a given number of color. You need to say yes or no. And this is what we call it as decision-making problem. Wherever you want to check for something, check whether if this is right or wrong. Check if the given number is a prime or not. Decision-making. Okay, so check whether something is true. Check whether it is an Armstrong number or not. Okay, check whether there exists a path or not. So when you come with, like this or that, yes or no, true or false kind of scenario is coming up, that problem will get into the category of, like decision making. And there is no common strategy for all decision making problem. If you categorize it into decision making problem, you will have a, like a very, like fixed number of techniques will be available. So it will be easy for you to, like identify which technique to use, which technique not to use for a decision making problem. Okay, let us get into every domain later, but I just wanted to put forth like what would be the, like the different types of problem, how to identify it. So one problem is, like the type of problem is graph is provided, number of color M is provided. Now using the number of color M, okay, using M number of colors, we need to check whether this entire graph could be colored or not colored. That's one thing. That's one type of question. And the second kind of question I will tell you, graph will be provided. Okay, graph will be provided, but no number of colors will be provided. Where graph will be provided, where no number, number of, like color number, how many colors are allowed, that will not be provided. What is that you need to find is, you need to find the minimum number of colors. You need to know, look at the graph and say, what would be the minimum number of colors that would be required to completely color all the vertices by following the constraint provided. So when the question is like find the minimum or maximum kind of stuff, okay, when it is going to be like minimum or maximum kind of question is coming, minimum, maximum, shortest, longest, okay, largest, smallest. So when such kind of question is coming, that kind of question comes into optimization problem. That comes into directly, like optimization kind of problem. Okay, so first type of question I'll tell you, graph G is provided. First type of question, graph G is provided. Number of colors also provided. They're asking to check whether the given number of color, whether the entire graph could be colored or not colored. That's first type of question, first scenario. Second type of question is only graph is provided. And the question asked is, what would be the minimum number of colors that would be required to color the entire graph? That would be required to color the entire graph. Okay, so that comes under, like optimization. The second category comes under optimization. First category of question comes under decision making. Now, the next one, very important thing is, a graph G is provided. Okay, a graph G is provided, and also the number of color M is provided. The number of color M is also provided. So graph is provided and the number of colors is also provided. By using these two data, what you need to find is, you need to find, using this M color, what are the different ways of coloring the graph. Like for example, if I have red and green color, only two colors are provided. One is red, the other one is green. First of all, I will be coloring C1 with red color. And I think C2 cannot be given. C2 and C3. If C1 is taken as red, C2 cannot be colored with red, and C4 also cannot be colored with red because they are adjacent. So definitely they both have to go with green. Suppose if C4 and C2 is going with green, definitely C3 cannot go with green. So I can make it as red. This is one possibility. The other possibility will be this C1 and C3 can be colored with green, and C4 and C2 can be colored with red. Like this, there can be many different possible way of coloring a vertex. So we need to find all the different possible way of coloring the entire graph. I need to find, I don't want to find whether it can be colored or not colored. I want to find how many different possible ways to color it. I want all the different possible ways. C1 colored with red, C2 colored with green, C3 colored with red, C4 colored with green. Next possibility I need to go with. And if there is any next possibility. So whatever is the possible way of coloring the graph, all the possibilities with vertex number and the color, everything should be find. So this question comes under enumeration. Enumeration in the sense, when there is a question which is asking you to generate all the possible solution. When there exists a solution, where there exists a question, okay, if there exists a question, okay, if there exists a question that asks you to, that asks you to generate all the possible solution, okay, that if that asks you to generate all the possible solution, then that comes under enumeration. So decision, optimization, and enumeration. What is enumeration? If a question is provided and they are asking you to generate all the possible answers. Okay, if they're asking to generate all the possible answers, then we go with enumeration. Then we take that problem and keep it under enumeration category. So there are three type of problem I have spoken. We have few, more different kind of problems, but these are the mainstream, three mainstream kind of problems and commonly used type of problem also. So the three type of problem is decision making, optimization, and enumeration type of problem. So is it, first of all, everybody is clear with this three type of problem that exist? What is the difference between all the three different types of problem? Is it everybody clear with those things? Now, shall we take, always this enumeration category will come under, come into backtracking. So this enumeration type of problem, 95% it will be, we will require backtracking to be used. Okay, 95% of the enumeration type of problem will require, backtracking strategy to be implemented. Okay, so now, yes. Okay, so now what we will do is we will just go with, discussing about backtracking. So backtracking is, first of all, the prerequisite, the main prerequisite of backtracking is understanding of recursion concept. Okay, if you're very good at recursion, then backtracking is like, walking in a piece of cake. Okay, so, you have to be, literally very, very, very good at, recursion to be, very good at backtracking. So because both are codependent actually, because backtracking is actually a property that is exhibited by recursion. So we need to have a good knowledge of recursion. Everybody knows recursion, knows recursion, what is recursion, everything basically, but we need to understand the depth of it, what is the behavior of it, and what kind of scenario, what kind of behavior it will be exhibiting, what is the power of recursion, what is the drawback of recursion. All this understanding have to be there, first of all, to get into backtracking, because once you very clear with recursion, Backtracking is very easy. I would tell you, any problem that is given to you will be easily able to crack it. Okay. So now, first of all, let me discuss few things about recursion, which would be abstractly required for, getting very deep into backtracking. So let me, introduce you about the very basic kind of abstract content. As I said, abstract content of backtrack, I mean recursion. So when we come to recursion, everybody knows that recursion means calling a function inside the definition of the function. If a function is getting called inside the definition itself, then we call it as recursion generally. But that's not solely recursion. There is different types of recursion is available where the definition changes. When the definition changes for every different type of recursion that we have. So when you come to recursion, I just wanted to list out the types of recursions that we have. Okay, so let me list out all the different types of recursions that we have. So the first type of recursion that comes here is head recursion. Is something that comes first. Okay, so head recursion is the first thing, and then next tail recursion comes, and just 1 minute, students. Okay, I think let me just let me little bit slow down myself. Okay, so we need to first of all we need to strengthen our skills. Okay, we need to strengthen our skill, our techniques in recursion first of all. Okay, so see, learning a lot of programming techniques. It's like learning a sport. Every sport has its own technique. Am I right? Like you take badminton, you take cricket, you take football. Every single sport, if you take, there is a lot of different technique available. Okay, to be a good sportsman, you need to be having a good uh, skill, technical skill in that particular techniques. Your techniques is very important for that particular language. And if you take the greatest of all time people in any sport, if you take like tennis, if you take everybody's technique is very important. Okay, so to become a a good programmer, the techniques that we learn here, the techniques that we follow, the unique techniques that we learn, that's very important to become a good programmer first of all. See, you need to compare it with the practical life first of all. Programming is not something which is completely isolated from you. It is something which is part of all the techniques that we learn, programmatical techniques that we learn. They completely taken from the practical life. Okay, so we need to first of all relate it. Okay, relate it with ourselves, make it interesting a little bit. Okay, so now first thing is I just see why I'm telling this is techniques are very important. All the techniques that we learn, programmatical techniques that we learn, are very 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 important. See, for example, you take any a person from sports. I always refer to the sports. So when you just take somebody some greatest person of any sport, if you take for example like when you take Federer or Rafael Nadal, or Sachin Tendulkar, when you take these people, just remember something. They have learned a lot of techniques of their own sport, and first of all they know different scenarios. They have played for a very long time. They know when difficult situation come, which is very difficult ball, when a ball comes like that, what we have to do, how to tackle it, which technique to apply at a right point of time, which technique will work out according to the scenario, which techniques will not work out according to the scenario, according to the the weather conditions of the game. So everything it has to come by practice, it has to come by experience. So first thing you need to understand is nothing will come at the first attempt. Even it is anything you say, even programming that you learn, any subject that you learn, it has to be in a practice. Okay, so first I'm going to teach you a specific technique. And this technique you need to repeatedly, you need to practice repeatedly, you need to look into it so that you can get to the you can get a grip to it first of all. Okay, so first thing, we're going to learn a technique called as recursion. And coming to recursion, there are several different types of recursions available. Whereas the first type of recursion is head recursion, and the second type of recursion is called as tail recursion. Third type of recursion is what we call it as tree recursion. And the fourth type of recursion is what I call it as nested recursion. And the fifth type of recursion is what we call it as indirect recursion. So these are the 5 different types of recursion that we have. Okay, so before getting very deep into all these different types of recursion, let me take a very simple type of recursion. Okay, simple code I will take. Simple, like recursion example I will take, and we will just first of all, like discuss how that simple code could be, like it could be, traced first of all. Traced in the sense how it will be taken to the CPU and how the execution flow of a very simple recursion will be. Let us understand that. There are a lot of, terminologies, a lot of concepts that we need to learn within that tracing concept itself. So let us just discuss about that. So first, for that, let me take a very simple code for like doing such kind of like tracing. So I will just take like a piece of code in C. So stdio.h I will just take. Then let me come to like it is going to be return type void. I'm going to write a function with the return type is void, and the name of the function is func fun, and it is going to take a parameter called as n. Then coming inside the definition of the function, I will be checking if n is greater than 0, and this we call it as n greater than 0, right? This we call it as, actually we call this as base condition or base criteria. Why we give this base condition or base criteria is, for example, you just take a concept of looping. What is the purpose of looping? Purpose of looping is take a set of instruction and to repeat the execution of the set of instruction for multiple times is the purpose of looping. Same set of procedure or same set of instruction needs to be repeatedly executed again and again. What is recursion? Recursion is also repeating the same set of procedure again and again. So there is some similarity between looping and recursion, where both is going to repeat the same set of instruction again and again repeatedly. Both has a lot of differences also. We will learn about the differences. So when the same set of procedure or same set of instruction is executed, keep on getting executed repeatedly. Okay, when it keeps on, like executed, keep on repeatingly, it should definitely have an end point, terminating point. Am I right? It should have a stopping point, terminating point, where it should stop. And that is why, like in while loop you take, or, like if you take, when you take while loop, or when you take a simple, like for loop, whatever loop that you take, it will have, like a separate section, like for conditions, where a condition is provided. Okay, where a condition is provided, and based on that particular condition, okay, so we will write this using this condition, we will be stopping. So we like we fix an endpoint for a process where the same set of instruction is repeatedly executed. So when loop, when we give such a condition for stopping, right, stopping condition is there, termination condition. Similarly, for recursion also, we should have this stopping condition, terminating condition, termination condition, and that termination condition is base condition, which we have provided here. Either you can use this condition to continue a recursion, or either you can use this condition to stop it also. That is up to us. So now I'm going to use this condition. If this condition is true, I'm going to continue my recursion. If this is false, I will stop it. So first thing that I will be doing inside this if condition is, I will just write a printf statement where I'm going to print the present n value available. And after printing the present n value, I'm going to call the same function inside which presently we are. So func, and by calling func, I will be just simply passing n minus 1 as a parameter. And the next line is going to be, again, I'm going to look into printf, and I will be printing the present value of n first of all, then close parenthesis and the semicolon. Now this if condition is over. And if this condition is false, we will stop the recursion, whatever we are doing. And now comes the main function. Whereas in main function, what I'm doing is main function. I am going to start with taking a variable, integer variable a, assigning the value to 3. And the next line, I'm just going to call the function func by passing the parameter a to it. And there comes the close curly braces for the main function. Now coming inside this func, I'll just go with the first line of if condition, and then I'll just go for like second line here, and then comes third line here, and then comes like fourth line, and then comes like here coming to main function. Here it comes like first line, and then here it comes second line. Okay, fine. Okay, so now, like before getting into this, first thing, before getting into the tracing part, first thing I'll tell you, whatever code that we are writing, whatever code that we have written here, over here, and whatever we have written, this file will be called as .c extension file. And .c extension file, we generally call it as data file, because in here we have used some natural language. Okay, what is natural language? You could have heard about natural language processing, NLP. What is this NLP is all about? Natural language. See, what is that generally natural language? What we call it is NLP, natural language processing. Natural language processing is just capturing the human understanding languages, okay, and processing those things, manipulating that, making analysis over that. That is what just NLP is all about. See, you could have heard about the new, like feature that is booming off is your, when you just take a screenshot, or when you just place your camera, mobile camera on some text, some human language, and the camera is now able to capture that particular text, and it is capable of translating it and showing the picture, same picture, showing it by, like by converting it into another language, whatever we claim. Okay, so it's what we call it as natural language processing, NLP. So natural languages, the languages that are understood by human is called as natural language. English is a natural language. Tamil is a natural language. Telugu is a natural language. So all kind of languages that are understood by human is what we call it as natural language. And if a file completely consists of natural language, which can be understood by only human, which cannot be understood by CPU or computer, then we call that file to be data file. Similarly, natural language file, that is data file, will never can be executed by CPU because they cannot be understood by CPU. So what happens is we bring in something called as compiler. I think hope you know about this compiler concept. So I'm just brushing it up. Okay. So you just take a compiler in between. A compiler will be having two different phases actually. The first phase is what we call it as syntax analyzing phase. So the first phase is syntax analyzing phase. And the second phase is, so first phase is syntax analyzing phase, and the second phase is, so first thing is syntax analyzing phase, and the second phase is translation phase, or translating or translation. So first, in terms of syntax, like analyzing phase, what will happen is, see, what is syntax we need to understand. For example, let us take English. In English, we have something called as grammar. Can somebody use your chat box and tell me what is this grammar is all about? Can somebody use your chat box and tell me what is this grammar is all about? For English, every language has its own grammar. Like Tamil has its own grammar, Telugu will have it, Hindi has its, English has its own grammar. So what is this grammar of a communication language? What we call it is, what is this grammar is all about? Can somebody, what the word grammar says? Okay. Okay. See, grammar of a particular language, we can say it's a set of rules or protocol. Okay, it's a set of rule or protocol, because there are a lot of words available in English. Any language, if you take, there are a lot of words will be there, vocabularies will be there. When you take all these words and vocabularies, we have defined a set of rules or protocols of every word, where it has to be used, how it has to be used, and when it has to be used. Okay, it is a rules and regulation set of protocol of each and every word available in the language, where it has to be used, when it has to be used, how it has to be used. All this is predefined. That's what grammar is, right? Similar to coming to syntax, if you take the programming, any programming language like C or C++ or Java or Python, whatever language you take, every language has something called as keywords, available keywords. That's what I'm just comparing it with the words available in a particular language, communication language. So when there are a lot of keywords available, there is a set of rules, protocol of every keyword, where it has to be used, when it has to be used, and how it has to be used. And that is what we call it a syntax here in programming language. The same set of rules and protocol which we have defined in a communication language, we term it to be grammar. And the same set of rules and protocol which we have defined out here in programming language, we term it to be syntax. So the first line is, the compiler will act like an English professor. When you go to an English exam, you write an English essay and you give your paper, a test paper, to your English professor. What your English professor will be saying, line by line, he will be checking whether is there any grammatical mistake is there or not. Now the compiler will be doing the same process. It will be checking line by line whether is there any syntactical mistake, syntactical error is there or not. Suppose if there is any syntactical error, it will stop. The compiler will give instruction to the user that there has been some syntactical mistake available, and it will not proceed to translation phase at all. In terms of compiler, I'm speaking. We have interpreter also, where interpreter will be having a different behavior. Let us just now stick on to only compiler. But if the syntax is completely, it is followed, then the code will be traveling from syntax analyzing phase to translation phase. It will be traveling from syntax analyzing phase to translation phase. Now coming inside translation phase, what will happen is, we know ultimately CPU can understand only zeros and ones. It cannot understand any natural language. So whatever we have written in the natural language, let us convert all these things to zeros and ones. So translation phase will be taking care of converting the .c file to zeros and ones. So this translator will be translating the whatever code that we have given to a separate file. The same file will not be converted. It will create a new file, where this new file will completely consist of only zeros and ones, which can be directly understood by CPU. So the original code, whatever we have written in .c, this file only is converted to this zeros and one, and the extension becomes .exe. And in terms of Windows, I'm speaking. Okay, in Linux, it will be .out file. In Ubuntu or any Linux oriented system you use, it will be either .binary file or otherwise .out file. But in terms of Windows, it will be .exe file. And coming to .exe file, what is the expansion of .exe? Executable file. Why it is called as executable file? Because it consists of completely binary thing, which can be directly understood by CPU. So directly CPU can execute it. So it is a directly executable file. .c is not executable file, because it is in completely in a human understanding language. It cannot be executed directly by CPU. So it is in a non-executable format. But this is zeros and ones, it is in executable format. That's why. So all the files which are in executable format directly, they are always they be in the extension .exe. You go and take any softwares. You take Google Chrome, you take Word, you take you take Edge, you take Office, like Word, Excel, PowerPoint, you take Notepad, you take WordPad, Paint, any software that you take, every software is going to be in .exe format in terms of Windows is concerned. What are all they convey? They convey that .exe file completely has only zeros and ones, and it can be directly executed by CPU. And when that file is directly executed, automatically all the zeros and one file which is inside it will be executed, and the final output is the software. When you take word.exe and when you double click on it, the execution of the program will begin, and automatically you seems to have this word, like the software appearance. Okay, the window to appear. Okay, so all the softwares, they are all program files. They are called program files. See, notepad.exe is a program file. I create a .txt file using that particular software, that is data file, which will completely consist of only natural language. So when a human understanding language is coming, that file we call it as data file. When a computer understanding language is coming, that file is called as program file. So there are two different types of files there: data file, program file. Data file cannot be executed by CPU, whereas this program file can be executed by CPU. Now I have converted my data file into program file. Now I need to take this program file and I need to send it to CPU for execution. Now coming to CPU. CPU is not a single entity. CPU is just a name that we have given to the entire cabinet, where motherboard is available, where, like in motherboard we have, we have arithmetic logical unit, we have control unit, we have input buffers, output buffers, we have main memory, which is random access memory. All these things together constitute, all these things together is what we call it as CPU. CPU is not given to any type of hardware. A CPU is a name which is given to the consolidation of all the hardwares coming inside the CPU cabinet. Okay, so if you say that this program has to be taken to CPU for execution, you need to say exactly inside CPU which component will be taking care of it. Inside CPU, there is a component called as main memory. The next name, other name for it is what we call it as random access memory, which is what you're very, very, very familiar with, because any like mobile phones that you purchase, any new laptops that you're trying to purchase, the first specification or the second most specification that comes to your mind, apart from the like the processor, the next immediate specification that comes to mind is actually random access memory. How much memory? Okay, it's either 4 GB or 8 GB or 16 GB. That's the next specification that comes to the mind. So inside this main memory only, executions will be always happening. Now you need to think of something. Random access memory is also a memory device. Memory device is always used for storing purpose. We also have hard disks. Every system, if you take, like mobile phones you take, or laptops if you take, computer systems if you take, we also have random access memory. Also we have, that is main memory also we have. At the same time, we also have main memory we have. Also at the same time, we also have like something, like we call it as hard disk. Hard disk is also a memory device. Random access memory is also a memory device. Why do we want two different memory devices at the same system? What is the reason? Why do we require two different kinds of memory at the same time? Why do we require that? Can somebody tell me? Why do we require RAM and also like ROM at the same time? 1 minute. 1 minute. People usually says that RAM is a temporary storage, so we want a permanent storage. No, we see certain computer architectures have made RAM a temporary storage for some purpose. By general, they are not temporary storage. We have given this volatile property that like the computer architectures who designed the initial computers, they have given RAM the volatile nature. We have incorporated that nature. Okay, so but why do we make that random a temporary storage? Why do we make this particular like hard disk a permanent storage? Why do we require like both things together? That's what my question is. Can somebody like post the answer for that? Okay. Okay, I'll take few points. Okay, I'll just take few points here. First point that I saw is first thing that I saw. First point that I saw is RAM is used for processing, where hard disk is used for storing. Yes, great point. Okay, RAM is used for processing perfectly, whereas hard disk is used generally for ROM is used generally for storage purpose. So why do we use RAM for processing? Yes, next point comes is random access memory is very faster in processing a data, but whereas hard disk is very slow in processing some data, executing something, it's very fast, very slow. So if random access memory is very faster in processing some data, why can't we use random access memory for the entire purpose, for entire storing, execution, for every purpose? Why can't I store only random access memory? Then the next point comes as where random access memory is very costly in nature, whereas hard disk is very cheaper in nature comparing to a random access memory. So altogether, if you see, so random access memory being very costly, like people thought that the computer system has to be like efficient, cost efficient also, and also at the same time it has to be process execution efficient, fastness also they have a check on. So what they planned of doing is they took a very limited amount of memory of random access memory and limited amount of random access memory, and they placed in the system so that the processing could be really faster. Same time they used a like a large amount of like hard disk for storing purpose. Not every data is going to be processed to be stored. So if a data have to be stored directly, I will take it to hard disk. Only if the data needs to be processed or manipulated, then I will copy those data from hard disk to random access memory. I'll do the process and I will send it again. Okay, so only when a program is in running state, when you just take like any software, when the software is in open state, they will be inside random access memory. While they are in execution state, they will be inside random access memory. But once the execution is over, if you're closing a software, automatically all the files which is related to the software will be it will be reaching the hard disk. Okay, again it will be reaching the hard disk. Okay, fine. Now coming to this main memory. Okay, coming to this main memory will be divided into 3 different segments, where usually what happens is the topmost segment we call it as stack, middle segment call it as heap, and the bottommost segment we call it as code section. But for the better like the way of explanation, it would be easy to, I'm just changing the structure where the upper part, let me consider it to be heap, and the middle part we consider it to be stack, and the bottommost part we call it, we are going to take it to be code section. Now our code will be reaching this main memory. Inside main memory we have 3 different components. Exactly inside which component the code will be reaching, whatever .txt file that we are taking, that .txt file, first of all it will be reaching the code section, and in the code section whatever the code that we need to execute, that code will be taken and it will be stored here in the code section. And then the execution starts, and for maintaining the flow of execution, any data needs to be stored according to the program. For those, if we require any memory to be stored, if we require any data or any information to be stored for the program to be executed, then we will take help of stack memory and heap memory for storing purpose, storing any kind of data, any kind of information. Then we will use either stack or heap. Stack and heap memory has a lot of differences. Okay, we will learn about their difference in properties, difference in the behavior, everything we will discuss now. We'll discuss now. Okay, but we need to know that stack and heap memory will be used for storing data and information related to the execution of the program. Okay, all these things will be like it will be stored either in stack or heap. We will look into the information, the differences of both those things also. Now coming here, one more thing that I need to teach you now is what something called as activation, a terminology called as activation area or activation record. So what is this activation area or otherwise activation record is all about? Okay, what is this activation area or otherwise activation record is all about? why we require this activation area, activation record. See, for example, this is a simple program, right? Where the execution will be starting? Execution will be starting with main function. See, even though this code also will be stored in some memory location only. So every line, this line is available in 1000 memory address. This is available in 1003, 1007, 1010, 1013, 1016. So every line will be, or every single character, or like some single character, it will be available in a certain memory block only. Okay, you have to remember that. So now, for example, the execution starts from main function. Then I execute first line. Then once after that, if you see here, there is a function call. Once I see this function call, I will jump exactly to that function call position. There I will jump. Then from there, I will just keep executing line by line. I'll just keep on executing it line by line. And once I just execute it line by line, what will happen? Once this is completely over, all the execution is over. Again, from here, I will jump to the same position from where we jump actually. From second line, I jumped to FUNC. Now FUNC is over. Again, I need to jump back to the same line. So when you're able to see, can you able to figure out that the execution flow, the control flow of execution, it is not linear. We are not executing line by line. Because of the function concept, we are jumping here and there. From second line, we are jumping to some line, like from second line of main function, we are jumping to first line of FUNC. Then after fourth line of FUNC, again we are jumping back to third line of main function. So we are just executing it in a different, like it is zigzag manner, complex manner only execution is happening. Execution is definitely not happening in a linear way because of the function concept. Is that, first of all, everybody is able to observe that very clearly? See, about a heap and stack memory, we will learn. I have not still explained about stack and heap. Stack and heap is used for storing data for the execution of the program. During the execution of the program, any specific data needs to be stored, then we will use either stack or heap. I'll explain about that. But coming here, first of all, can you able to figure out when you take some program and when you look at the execution flow, they are not linear execution flow. Like line number 1, line number 2, line number 3, line number 4, line number 5. So it's not like linear. Line number 1, line number 2, line number 3, because of a function call, from line number 3, I need to jump to the line number 1 of a different function. Then after that function is over, again, I need to jump back to the main function itself. So we have some zigzag kind of flow we have. I think that's for something that you might understand clearly by looking at the program that we have taken so far. Now who says to jump after second line? Who's telling after second line you need to jump to somewhere? Okay, after fourth line is executed, you need to again jump back to the same line, second line. Who's having that? That's where activation area comes. Activation area is a closed memory space. Inside your stack memory. It will be created. It is going to be a closed, closed memory inside stack memory, and it is created for every function call. And for every function call, which line we are presently executing. If there is a function call from here, which line I need to jump, which memory address I need to jump, and after the execution is over, where I need to return back, all this information related to the control flow, okay, flow of execution, right? All the information related to the flow of execution is stored inside this activation area. So what is this activation area is for? This activation area is for storing information related to the flow of execution. Presently, if you create activation area for main function, you have to store presently which line I'm executing. Suppose if I'm just moving here from here to func of A, so which line I stopped my execution. Okay, second line I stopped my execution. I'm going to func. And after executing everything over here, then when the function execution is over, then again I'm returning back to the same second line. So who will say that after fourth line, I need to reach the second line of main function? All this information will be available inside the activation area that we are going to create for every function. So you don't want to understand more about activation area. One thing that you need to understand about activation area is it is used for storing information related to the flow of execution. Do you understand that? First of all, I will explain you by showing one example. Okay. Okay, let me make it a little slow, because I too even feel that I'm just going a little fast. Let me slow down a bit. Okay. Yes. So what is activation area? Why activation area is required? Activation area is a closed memory space. Activation area is a closed memory space. Okay, it is a closed memory space inside stack memory. It will be created inside stack memory. Activation area is not stack memory. It is something which is created inside stack memory. For every function call, this activation area will be created. And inside this activation area, we will be storing the information related to the flow of execution. Presently, which line number is getting executed. Presently, which line is getting executed. Okay. Presently, what data I want to store. If I need to return back from one function to another function, which address to which function I need to return, to exactly which memory address I need to return. All this information, yes, activation area, activation record, both are same. And this is the purpose of activation area. Is it everybody clear with the purpose of activation area? Is it everybody clear with the purpose of activation area? Just tell me kindly in the chat box. Okay, fine. Okay. See, again, I will just, okay, activation area concept, I will just explain in a moment. But one thing is activation area. Okay. Activation area is used for storing information which is related to a particular function call. I will explain, we will just start, like tracing the entire things out. So while we start tracing out the entire stuff, we will get to understand things better. So first better, what we will do is, I'll take the copy of this entire code, whatever we have written here. I'll paste it here. Now let me take a main memory on the right side for starting the tracing purpose, where we will understand about activation area, everything, every stuff we will understand. Okay. Fine. So consider the middle part as a stack, right? So now mainly we will be using stack. This program does not use heap memory. I'll tell you why and when the heap memory will be used. All these things I'll tell you. First, where the execution will be starting. Execution will be starting from main function as usual, right? So when any function is called, let it be main function or any function, but when there is a function getting invoked, for every function which is getting invoked, there is a corresponding activation area which will be created inside a stack memory. And this activation area is just a closed memory space inside stack memory. That's it. Now inside this, what I will be doing is, this activation record was created for main function, and this activation area will also have a like a keep note of which line is presently getting executed. Now presently I'm standing at line number 1. What is line number 1? I should take a variable A and I should store data 3. So inside this specific activation area, I require some data to be stored. So I will create a memory block for that particular variable A, and the value 3 will be stored inside this particular box. So first line is executed. What is first line? Creating a memory block, integer memory block with variable name A, and the value inside is going to be equal to 3. Now, second line is going to be function call. We are going to call func of parameter A. So for that function call, one more activation record will be created on top of the existing activation area. Okay, one like activation area will be generated. It will be created on top of the existing activation area, and this activation area is particularly for func of A. Okay, func of A. What is A here? A is 3 from main function. So whenever there is a function call happening, automatically what we need to do, we need to create an activation area. Now, I was just speaking about creating activation area. Is there any possibility of deleting the activation area? Definitely. Something which is created inside main memory will definitely be destroyed at some point of time. So if I'm creating an activation area, when I'm creating activation area, can somebody tell me when we should be creating activation area? When we should be creating activation area? What is the procedure for creating activation area? What kind of situation we will be creating activation area? Just do tell me in the chat box. Let us make it interactive so that I can also be a little slow, and even you can get better understanding of things. Okay, see, listen carefully. Whenever you see a function call, activation area will be created. That's very simple. Whenever you are seeing a function call, activation area will be created. Now, what about deleting activation record? If you want to delete activation record, there are two ways of deleting activation record. Suppose if the closed curly braces of that respective function call, for the main function call, if I'm creating activation area, suppose if the closed curly braces of that main function, or otherwise return statement, okay, or else if return statement is available, then that particular activation area, respective activation area, can be deleted. I think you remember in Turbo C and the old C compilers, if you take, when you give integer main function inside, without giving return statement, return 0 or return 1, without giving that, the program execution will not stop. It will throw some error. It will keep on behaving differently. Why? What is the reason that? Because previous structure, if you take, only if a return statement, when the function is having return type, definitely if a return statement is provided, then only the current activation area could be deleted. And that was the reason why, if an integer main is given and without a return statement, why we were not able to end of the we cannot successfully end the execution of the program successfully. But nowadays in the modern compiler means the packages of C++ were merged. Okay, now in the modern compilers, what all the online compilers, the online platforms, everybody is using, right? In the modern compilers, if you take, now what they have done is, activation area will be deleted either in two ways. Either if the closed curly braces of that respective function block is executed also, it can be deleted, or otherwise if return statement is seen also, it can be deleted. Two ways. But so far for main function, still the closed curly braces was not executed. Only now we are presently at line number 2. So I was not able to delete this activation record. Before deleting the activation record, I was just having another function call. So I definitely need to create one more activation area. So where I have to create, if there is already activation area available, if there is already activation area available, then I will create my new activation area on top of the existing activation area. That's why this memory section get a name stack memory, because literally what we are doing, we are taking and we are, like it's like we are inserting a new element at the top of the stack, and when we want to remove also, only the top element can be removed. Same property of stack will be exhibited by this particular memory block. That's why this particular memory section was given the name stack memory. Okay, now let us come to the next, this activation area. So always the topmost activation area will be active. Suppose if you want to access main activation area, func activation area have to be deleted, and after you enter into main only you can access it. By like by standing inside func, you cannot access main. That's not possible. Always the topmost activation area can be accessed. All the other activation area cannot be accessed. So if you want to access it, you want to delete all the activation area which is coming above it. Now coming to this func function. Okay, what is that? First of all thing is here, see, in the function call, whatever you're passing is called as actual parameter. And in the receiving side, in the function definition, whatever parameter is available, it is called as formal parameter. Now, whenever the function call is happening, automatically, or whatever the actual parameter value is, that actual parameter value will be copied to formal parameter value. So what is that formal parameter is? Variable called as integer n. So in this func, I will create a variable with, I will create a memory block with variable name n. And what was the value that was passed? 3 is the value. So I will just insert the value 3 here. Step 1 is over. Now I will enter inside line number 1. I will start with line number 1. You see here, I'll start with line number 1. What is line number 1? We are checking whether the present n value is greater than 0. What is the present n value? 3. Is it greater than 0? Yes. Condition is true. When condition is true, I will enter inside the if block, and second line I will execute. What is second line? Printing the present value of n. What is the present value of n? The present value of n is equal to 3. The present value of n is equal to 3. Okay. What is next? Next, I will have to execute after second line. I need to execute third line. But what is the third line? What is the third line? Third line, it is a function call, right? Remember, forget that it is a recursive call. Just keep in mind that it is some function call, right? So in the third line, I'm seeing a function call. Whenever a function call is seen, what we need to do? What is the procedure? Whenever there is a function call, what is the procedure? Tell me in the chat box, what is the procedure whenever we see a function call? Yes, activation area have to be created. So now let me stop my execution at line number 3. And because of third line having a function call, let me create one more activation area on top of the existing activation area. And this activation area is also for func, but for what parameter? N minus 1. What is the previous n value? 3. So 3 minus 1, 2 is the present parameter. So coming inside, I will create a memory block for variable n. And what is the present parameter value that we received? 2. So we will just simply take 2 and we will place it inside. And after placing this, again, we will start from first line. What is first line? Checking whether the given number n is greater than 0. Yes, 2 is greater than 0. So my condition is true. I enter inside if block where the second line is printing the present value of n. What is the present value of n? 2. So 2 will be printed. Initially 3 was printed. Now 2 is printed. Now after that second line, what is the next line? Third line. So now what is the third line actually? By now standing at third line, what is the procedure that I need to do now? By looking at this third line, what is the next procedure that I need to do now? By standing at third line presently, what is the procedure that I need to be following now? Again, I need to create a one more activation area. Exactly. So I will be creating one more activation. Let me keep this itself one more activation area. And this is also for fun. See, what is a parameter? N minus 1. Previous n is 2. 2 minus 1 is equal to 1 will be the new parameter value. And now coming here, I will start with first line over here, checking whether the present n value is greater than 0. N value is 1. So a one memory block would have been created inside with variable name n and value is equal to 1. So hope one thing you can remember, one thing that you can observe here. Different memory block with same variable name is not possible, that generally we speak, but they are possible in different activation area. So every different activation area is of different function, right? So that's why people say in one function, it like if a variable is n, the other function also same variable name we can take, but for a different memory block we could take. So that we need to understand from this activation record. Okay. Now first line condition is true. I enter into second line. What is second line? Printing the present value of n. What is the present value of n? 1. So 1 will be printed. Then I come to third line. What is third line? It is a function call. So where one more activation area will be created and that activation area will be taking parameter n minus 1, which is 1 minus 1, 0. And let me start with first line. What is first line? Checking whether the present n value is greater than 0. So I think the present n value is equal to 0, which is not definitely greater than 0. Condition is false. The initial base condition itself is false, n greater than 0. So when that base condition is itself false, what has to happen? I cannot enter into the if block. So I will not be able to execute second, third, and fourth line. I'll come out of the if block. Once I come out of if block, I see only the closed curly braces of the respective function. When I see the closed curly braces of the respective function, what is that I need to do now? What is that I need to do now? See, if you have any doubts, post it in the chat box, students. After completing the concept, I will explain, okay? But now tell me, now presently I'm executing the closed curly braces of that FUNC. So what should be the process that I should be doing now? Yes. So the present activation area have to be deleted if the closed curly braces of the function is there. So this function FUNC of 0, right? This activation area will be deleted. Once you delete this activation area, from there you will automatically reach the next immediate activation area. How? Because that activation area was also having the data of from where I came, from which line that activation area was created. That information was available. So from which memory block I came to the same memory block, I will return back. Okay, so I again come to the next activation area. And coming to this activation area, now remember something. You stopped your execution at line number 3 and you went to the next activation area. Now that is over. Now you need to continue from where you left it. So third line I left it. Now I should continue from fourth line. What is your fourth line? My fourth line is printing the present value of n. What is the present value of n? 1 is the present value of n. So that 1 will be printed. And after fourth line, what we have? After fourth line, we have nothing. I'll come out of if block. After coming out of if block, I see the closed curly braces of the function call. So once I see the closed curly braces of the function call, automatically this present activation area, it will be deleted. Automatically this present activation area will be deleted. Okay. Then I enter into the next activation area immediately. Then coming to this activation area is also stopped at line number 3. This activation area is also will be stopped at line number 3. Has stopped, already stopped. Now I need to continue from where I left. So I should continue from fourth line. So what is fourth line? Printing the present value of n. What is the present value of n? 2. So I will print 2. After fourth line, we will come out of if block. After coming out of if block, we see the closed curly braces of the respective function. So automatically when I see the closed curly braces executed, the present activation record, all the information, all the data inside that activation area also will be destroyed. And once you do that, you will enter into the next immediate activation area, where this activation area stopped at line number 3. I need to continue from line number 4, where line number 4 is printing the present value of n, which is 3. So I will be just simply taking 3 and I will be printing. And once fourth line is over, I will come out of if block and I will execute the closed curly braces of the function call. So where this present activation area will also be deleted. Then I enter into the next immediate activation area, main activation area, where last line that we were executing was second line. Now I need to continue from this next line. What is the next line of that? Next line is a closed curly braces. Once I see that, this activation area also deleted. Once your stack memory has become empty, then now you can say the complete execution of the program that we started has completely been over. Okay, so two things you need to understand is when to create activation record and when to delete activation record. I think those two things will completely give you a clear understanding of how this recursion codes will be working fine. Okay, so students, what we will do is it's 10:30 now. Let us go and take our 30 minutes break and come back. Once again, I will just do this, like execution a little quicker, and then I will explain you like why it is continuing. One question that you might have is after third line, how we are coming back to fourth line, how we are continuing from fourth line. That I will explain. And once we understand the few terminology concepts we need to understand here, that also we will explain. So we'll go take our 30 minutes break, relax ourselves, and then we'll come back and then we will continue what we are doing. Okay, is it okay for everybody? Okay. So go and take a break, relax yourself, and then come back. We'll continue.